Hi, everybody. Hey, I wanted to just give you a video for the weekend, just to talk a little bit about the type of work, the work that we've been doing in class, the simulations and the sampling. Okay, so I'm gonna start with samples. Okay, I'm gonna go over two things in this video. I'm gonna go over how we made samples out of a population, and then I'm gonna go over how we did randomization tests. Okay, so first part, let's go over samples. Okay, so a sample, like I have here in your notes, is a select group, a random. It needs to be, remember, large and random, that comes out of an entire group. Okay, this entire group is called your population. Okay, and to kind of remind you what we did, we had we talked about M&Ms, right? Where we said, well, we estimate that, or research says 25% of M&Ms are blue, right? We wanted to do a real world demonstration of this. So we created our own jar of M&Ms, right? Where we made sure that 25% of the M&Ms were blue by putting them, cutting a quarter of them as blue little squares. Okay. And basically all that we did out of this is we took samples, right? So we weren't going to take everything out because your sample size is not the size of a population. But basically, we took out maybe 30, right? 30 of our papers at random. And we found that generally speaking, yes, about 25% of them were blue, all right? Once we estimated this, this was our point estimate, and we saw that we had a margin of error. We talked in class also, margin of error gets minimalized the larger you make your sample. All right, so large random samples are a good thing. That's basically all we did to kind of simulate that, because we didn't have actual bags of M&Ms to record data over and over. Okay, the more importantly, I want to talk about randomization tests. Okay, so first, let's go over the four main steps of a randomization test. Right, step one is your null hypothesis. All right, this means you're going to assume that the treatment in the experiment, right? So again, we're testing an experiment to see whether or not the results, to see if whether or not the treatment caused the result, right? So first, we have to assume the null hypothesis. This means that we're assuming the treatment did nothing, all right? But we have to prove this, okay? And we're going to see in this next couple steps if we can do that, all right? Step two, we simulated the experiment, all right? So by simulation, I mean we took maybe some sticky notes, okay? And we recorded all of our data, right? One per each sticky note, all right? Then folded up sticky notes, put them into a jar, all mixed up, both groups, the control group and your treatment group, okay? And then we randomly took numbers out and put them into a group, right? So the first, we could call the first group the control group, and the second group the treatment group. All right, and we would find the mean for each one, and then find the difference. All right, so that's step two. You got to know how to conduct that simulation, and we've done that over and over, right? But again, make sure you randomly divide the cards into two treatment groups, compute the mean, find the difference of the mean, and repeat this, right? And you want to repeat this as many times as possible. Now, in our case, repeating this meant that we worked together, and all of us together would run these simulations, excuse me. All right, then what I want to show you is how these tests actually help us decide whether or not this is statistically significant. Okay, so here's your work from yesterday. All right, where we had two groups, a control group, people who took a test, and a treatment group of people who got a hug before the test, right? And we saw that it looked like people who got a hug got higher grades, but we had to prove that, right? So if we look at it, following all the steps that we took already, This is kind of like what your dot plot would make. And I know I don't have a dot plot feature here, but this histogram shows kind of what your dot plot would look like. Most of your differences are close to zero because it's random, right? But you saw really nobody got a difference greater than 5.1, which was the difference in our two groups when we actually got the data from the experiment. So because this value is in the outer 5%, I mean it is the outermost value actually, because it's in the outer 5%, you can conclude with good reason that the treatment actually caused the response. Okay, in other words, that the hugs actually caused the good grades. All right, but again, you couldn't just say that because of one experiment. We went and we proved this with simulations. Right, so it's very important that you understand how this histogram or the dot plot shows all of your randomization tests, and how your star right here shows your actual experimental data, and it shows, hey, look, it really was special what happened. It really was due to the hugs. All right. It wasn't by chance, because this is what happens by chance. The rest, right? This was not by chance. This was from cause. So anyway, that's a randomization test. And thank you guys for all the work that you've taken, all the time that you've taken to do this. And I really like how you guys have worked together and contributed. Okay. If you have any questions, as usual, please let me know. Send me an email, or talk to me before or after class, during class. But happy to help. Okay. Hope you guys have a good weekend, and we have a test on Monday. Bye bye.